In this video, I am going to introduce the concept of the electric circuit. This is just an introduction. Don't try to wrap your head around the math if you can't do so. This is just an introduction. You're going to have lots of practice. That's the way you learn electronics. You learn electronics through math. You learn math through your fingertips. And none of this math is going to be hard. It's very simple, basic algebra. And even when you go deep into electronics, it's just going to be simple algebra and trigonometry, which you punch into your calculator. So none of this is hard, so relax and enjoy. So this is a very simple circuit. I've got a battery, I've got a light bulb, and this is a switch right here. I'm using the value of 1 volt for a battery, and really this is not a battery, this is a cell. So you look in your old flashlight, each of the what you call batteries putting in is a cell. D cell, an A cell, AA cell, AAA cell. 9 volt battery is truly a battery. It has multiple cells in it. So I have a battery right here. The current flows from negative to positive through the circuit. Way back when positive and negative were arbitrarily assigned, and they blew it. They had a 50-50 shot. So the battery provides an electromotive force. That is like gravity pulling down on a mass, or having a water tower, the water coming down that pipe. The force. That's the best analogy I can cook up. And the current itself can be equated to water flow. So, and a resistance can be equated to friction. You rub your hands, you're providing a friction to the resistance to the movement, and it gets hot. So, as the current flows through the circuit, it goes through this resistance, creates heat, and then comes back in. So here's the variables we use. E equals a voltage, and I believe that comes from EMF, electromotive force, but it relates to force. I equals current. Now I was chosen by the French. Intensity of current, something like that. So that is a flow in coulombs per second. And a coulomb is basically a bucket of electrons. I know you can't put electrons in a bucket, but that's what it is. And that is 6.25 times 10 to the 18th electrons. That's a lot of electrons. So that's 625 with 16 zeros behind it. That is a very big number. So you got power. We're all familiar with power. You look at your light bulb, 100-watt light bulb, and that is just the voltage times the current. So here's your basic equations. E equals IR. Voltage equals current times the resistance. You can also do current, which I'm going to do a little later on in this. Voltage over resistance is current. Simple algebraic manipulation. And power equals voltage times current. So I worked it out right here. The current is 1 volt over 1 ohm. 1 ohm, 1 volt, 1 amp. The power being dissipated by this, the light bulb, will be 1 volt times 1 amp equals 1 watt. So you have a 1 watt light bulb right there. And all this is linear. So if you would put 2 volts into it, you'd have 2 watts. 3 volts, 3 watts. At some point this thing's going to get so hot that the light bulb's going to burn out. But that is your relationships. Now you have your switch right here. When you open your switch, the current stops. It stops the flow of current. You have a very high, infinitely high resistance right there. So with the switch open, the voltage over the resistance equals the current, which equals 1 over infinity, which is 0 amps. So that circuit is open. No current is flowing. And that's basically the gist of it. There's not much to it. There will be more. You will have series circuits where you have multiple batteries multiple lamps or resistors. We'll be using resistors in future videos, and you know, put them all in series. And then you'll have parallel, you know, where you'll have, you know, say another light like this. That's not very hard. A little more math in this series circuit, but I'll be introducing those in my later videos. Thank you.